In the previous video, we began to talk about what it meant to be independent and what we could do because of it. And in this, I want to continue that and then review some big topics about probability. So, the probability of an event must fall between 0 and 1. Outcomes. We've talked about these 6 rules already. These are old, and if you need to review them, you can certainly pause and do that. But this is our new rule. If 2 events are independent, meaning that knowing that one occurs does not change the probability of the other, then we can find the probability of A and B by simply multiplying the probability of A times the probability of B. So, like the example in the previous video with flipping a coin, each flip of the coin is independent of the previous flip. It doesn't matter if I've gotten 2 heads in a row. That doesn't change the fact that this new flip has a probability of 0.5 of being heads. And that's why we were allowed to multiply 0.5 times 0.5 10 times. Okay? Let me show you some examples of how we can use this. So, the probability of A is 0.4, probability of B is 0.2, probability of A and B is 0.05. So this is a little bit of review of Venn diagrams, but I'm going to add some independent stuff at the end. So I always start by putting 0.05 in the middle, which means that this is 0.35 and this is 0.15, because remember, the way we do this is we say we want the entire circle to be 0.4. The entire circle to be 0.2. So adding these up, I get 0.55. So of course that is the answer to A or B. I could write that down right now. It's the first thing. I always also like to just write down what's left outside. Okay, the rest of it, right? This creates the sample space. The probability of A complement, meaning not A. Well, a couple ways you could do it. You could come up here and say, well, if the probability of A is 0.4, the probability of not A is 1 minus 0.4. You could also say, well, if this is A, the stuff not in A added together will give me the probability of not A. It is 0.6. The probability of A and not B. So you're in A but not B. This is this part, just this 0.35. The probability of not being in A but being in B, so you're not in A but you are in B, so that's this 0.15 here. And the probability of not A and not B, well, that's that leftover 0.45. And finally, are A and B independent? Well, first of all, just because I don't want terms to get mixed up, sometimes people will say, no, they're not, because there's an overlap. Remember, that's disjoint. Disjoint means there wouldn't be an overlap. Independent, they can overlap, okay? But let's go to our formula. If things are independent, this should be true. The probability of A and B should be equal to the probability of A multiplied by the probability of B. So let's check that. The probability of A was 0.4. The probability of B was 0.2. That is equal to 0.08 if we multiply it together. And the problem, of course, is when I look up here and I was given the probability of that intersection, it's not 0.08. So we say 0.05, obviously not equal to 0.08. So are they independent? No, because we weren't able to multiply in order to figure out what the intersection was. So again, disjoint means they don't intersect. Independent means they do, and we can calculate the intersection by multiplying. Let's look at one more example. So, probability of A is 0.3, probability of B is 0.4. First, find the probability of A or B. Well, we don't know. We need more information. Now, in the next line, it says if A and B are disjoint, find the probability of A or B. Remember, disjoint means we just get to add. So it is 0.3 plus 0.4, it's just 0.7. If A and B are disjoint, find the probability of A and B. Remember, disjoint, I like to draw that Venn diagram. Disjoint means this. Here's A, here's B, so the probability of A and B is 0. If A and B are independent, find the probability of A and B. Well, we can do that because remember, independence means to find the probability of A and B, we simply multiply. 0.3 multiplied by 0.4 is 0.12. If A and B are independent, find the probability of A or B. Well, remember, A or B, this addition rule we had, our modified addition rule was that the probability of A plus the probability of B. Remember, if they're disjoint, you can stop right here. But if they aren't disjoint, you can still find the answer by doing this. So for us, we can do 0.3 plus 0.4 minus 0.12. We get 0.58. Okay, so again, independence has some powerful stuff with it, right? We get to do some things we couldn't have done before. We can actually find that intersection by multiplying. If A and B are independent, find the probability of A given B. Well, I want you to think about this. If two things are independent, that means that knowing that one happened doesn't affect the other. So the probability of A given B is simply the probability of A, because B doesn't affect A. So if B happened, it doesn't matter. So the probability is simply 0.3. Okay, and that's a good thing to think about and remember. I think a lot of times when you talk through it, it's pretty obvious, but if two events are independent, then the probability of one given the other is simply the probability of them each separately. Because if they're independent, they don't affect one another.